Hello everybody, I'm glad to be here. Today we are going to talk about this tolerance zone. I'm going to show it by mouse. Here, what should be this value, this tolerance zone for the position control here. In this situation, we are going to have a key with this tolerance, and we can see between the key and key seat here, we are going to have interference situation. By having this tolerance, we can see we are going to have interference situation between key and key seat. That's why we are going to call it fixed key. We are going to have two keys for this example, one at the top and one at the bottom. How we are going to calculate this tolerance zone for this situation? Here we are going to calculate the minimum clearance between key and hop. We can see it is 10 plus 0 and 10 plus 0.04. The difference between these two is 0.04 divided by 2. We are going to have this value 0.02. In case B2, we are going to have the same situation. Just here, we are going to have one key. The same as case B1, we are going to have interference between key width and key seat, and there is no interference between the shaft and hop. That's why when we are going to calculate this tolerance zone, we are going to have this formula. The minimum clearance between key and hop divided by 2 plus minimum clearance between shaft and hop divided by 2. The first part we have calculated in case B1, and second part the minimum clearance between shaft and hop. We can see it is 35.0, it is 35 minus 0.025 divided by 2. We have this value. The summation of these two values is 0.032. In case C, we are going to have again two situations. Let's say one key here or two keys here. When we have two keys here and we are going to use a screw to fix it, the key to the keyway, we can see there is no interference between the key width and key seat. And there is no interference between the shaft and hop. We are going to use this formula. We are going to calculate the clearance between hop and shaft slot divided by 2. Here we can see the width of the minimum clearance between the keyway and key slot divided by 2. Here it is 10 plus this value minus, what is here, 10 plus 0.022 divided by 2. Whenever we are going to have just one key, not two keys, the same as case C1, the same situation, there is no interference. We are going to have the screw. We are going to have just one key. We are going to screw it to the key seat here. The formula is the same as before. We should consider the effect of clearance between shaft and hop divided by 2. And here, the same as this C1, the part 1 is the same. And then we are going to calculate the second part, the clearance between shaft and hop, the minimum clearance. Let's see. We have minus 0.025. And here we are going to have 0 divided by 2. The summation of these two will be 0.041. That's why we are going to have this tolerance zone for the positioning. For this slide, we are going to summarize all of them in one table. When there is no interference, we are going to call it floating key. If we are going to have two keys or one key, we are going to have this formula. As we can see, when we are going to have one key, the effect of this clearance between hop and shaft diameter will be included. For all situations, it is highlighted by yellow color. And this effect comes here, this effect comes here, green comes here, this blue one comes here, this color comes here. in all these situations, we don't have any interference between, let's say, hub and shaft diameter. In case when we are going to have interference between key and, let's say, key seat, we call it fixed key, we are going to use this formula. If we are going to use a screw to fix key to the key seat, we are going to have this formula. We cannot see any effect of key width here. We can see key slot on hub and shaft. And here this yellow one is effect of diameter clearance between hub and shaft. Let's see. Yeah, here is the last example for today. Here for this situation, let's see this example. In this example, what we can see, by having these tolerances for the key, we have minus, we have here the key seat, we have this minus, we can see we are going to have interference situation between key and key seat. And also here we can see this one, the tolerance for the key is this value, and keyway we are going to have these tolerances, and then we are going to have also interference here as well. This is one issue. Another issue is clearance between shaft and hub. We are going to have interference here as well. Based on ISO 286, we have P6 here for the shaft, H7 for the hub. Here we are going to have interference fit between the shaft and hub. And by having this as standard, we can see we are going to have close interference, because here we are going to have H9, P9, these tolerances for the key and these tolerances for key seat here. It is here. As we can see, we are going to have interference here as well. What should be this tolerance zone for this positioning here? 0 mmc can be one solution. We need to make this table, and we need to calculate, and we need to think about this issue. Let's see for this situation, what is the maximum difference between key and the minimum distance of the slot here. Let's calculate here. Here the maximum width of the key is 10. The minimum size of the slot is 10 minus 0.051. The minus of these two values is 0.051. We need to make this table, and then for the shaft and hub, for this example, they are the same. We are going to use P9 for both of them for these two slots here. And here we can see the width of a slot is going to change in this interval, because we are going to have P9 tolerances here. We can see when we are going to have maximum material condition, when we are going to have the, let's say, this value for the key width, the tolerance is 0. By decreasing this value, we are going to have more tolerance zone, and the key is going to change in this interval. Here I can say in this situation we are going to deform the key, because easily we can see this 0.051 is the difference between key and key slot. Here it is smaller than this value, the tolerance is smaller than this maximum difference. That's why we are going to deform it. We need to think, what is the material? Do we need to increase this tolerance zone, or we should start it with 0 mmc? One of the solutions is put 0 mmc here, and for the second one put a little bit, let's say 0.1, 0.02, something like that, to not deform that much. But it is recommended to use 0 mmc for one of them. Again, In this example, we are going to have the same situation for the key and key slots on hub and shaft, but here we can see we are going to have N6 and H7. N6 and H7 based on this ISO 286-2, we are going to have transition fit. In previous example, it was interference fit because here we had P6H7. We were here, interference fit. But here it is between shaft and hub. We are going to have, let's say, N6H7. We are going to have this transition fit. Again, for this situation, one of the best solution is to have 0 MMC for one of them, let's say for Keyway, and then we are going to make this table to see what is the maximum deformation as we are going to apply for the key. Maybe it is good to have 0.02 or 0.03 here, and then we can see what is the maximum deformation of the key. And then by having that maximum deformation, we are going to calculate what is the level of stress on the key. In this manner, we are going to calculate what should be tolerance zone here. In all examples, as we have mentioned before, here there was not any interference between hub and shaft. Just for one case, we had this interference between key and Keyseat. That's why we can use this formula. But when we are going to have interference between shaft and hub, we cannot use this formula as we have mentioned here. We need to see what is the maximum deformation on key, and then we need to do a stress calculation. In that situation, we are going to decide what should be this tolerance zone for this position control. Next session, I'm going to talk about the indicators. I have used this reference for this topic for the Keyseat and Keyway. I can recommend you. It is a good book. Thank you for today. I hope you enjoyed. See you next time.